All right, guys, today we're going to talk about signal integrity for high speed signal simulation. So, right now, okay, let's focus only on this particular net right here. If I want to see any signal between this, so I have my layout right here and signal right here. Um, yeah, so it's highlighted right now. I have not routed yet. I'll route this two pins between these two devices. Um, okay, so these are the two devices that I'm looking at. One is here, and the other is here at the bottom. Yep, and this is the net we're going to talk about. So let me just rename this net. Press N, and that's a test. Sig. All right. So I'm going to just name this at right here. Let me rotate it. So the net name is Tasic. Okay. Right. Cool. Let me update this. Synchronize. Yep. So first, even let's say we don't have the layout yet, and I want to have a quick test in the schematic itself. So what I'm going to do is I can just right click on the net, assign analysis, signal explorer. Then I can choose the Orchid capture. Let me bring the Windows. It's on the other screen here. Yeah. So yeah, this is what we're gonna have. From here, what I'm gonna do is make sure there are we have both transmitter and receiver as well. Otherwise, we might have an error. So first thing, I'm gonna change to length. Okay, so assuming let's say for example the we don't have the layout yet, but we roughly know that it's going to be, let's say, um, 20 millimeter, just a random length. So change the time to length and expand all of this. I want this to be 50 ohm impedance and let's say 24 uh, millimeter. Okay, got converted 2 mils, which is fine. Velocity, yeah, it depends. So it depends on the substrate. Oh, this can be calculated. It depends on the stack up actually. Um, all right. So okay, what else do we need to do now? We're gonna set up the. Just click on the tri-state, the custom. Let's change this to, let's say, 500 megahertz and pattern 010 jitter picosecond. Okay, fine. Apply. Um, let's see again once. So this is a pattern that I'm gonna give. Um, all right. So okay, and I want to simulate this. To simulate it, I'm gonna click to analyze, simulate. Yeah, it's gonna launch Sigrity. It's launching on the other window. Let me bring this right here. Yeah, so this is the waveform that we so this is from U56 to U59, right? As per the schematic, it goes from U59 to 56. Yeah. this that you can enable the eye diagram just to check. Yeah, so this is what we have as per the um, stack of information, the length, impedance, and yeah, that's all. So this is from the schematic point of view. Now let's talk about the layout. All right, so let me put the schematic thing aside. Uh, Now what I'm going to do is this is the net that we are looking at. Let me route them. Um, this is at the top, I guess. Let's route it. Okay, and let's say let's put one via two, uh, yeah, just for the sake of testing. But okay, so this is what we have. We have two via, and this is the path, and we can roughly see the net length all of nets to be around 56.9, right? So we can see the subsection length as well. Right click here, and so element, it's like 32 so total is 56, right? The combined from here to here, including the two vias, um, everything, the net length. um, so what I want to do is I want to do the simulation. Let me save this file, and this we name the net name as test sig, right? Yeah, so make sure we open this in the Sigrity Aurora. Uh, this is the one that I'm talking about. Where is that? Yeah, Sigrity Aurora should be here. Yeah, and is it recording? Yep. Am I audible? Yep. Okay. So now what I'm going to do is first of all I'm gonna go to topology extraction workflow and click the design setup. And so first of all, we need the IBIS model for these devices. So the buffer uh, model, input output buffer model. Uh, so we are looking at this device and this device, right? So we need that to set them up. We're going to use a default model, nothing fancy. We can even download from it and the corresponding device manufacturer if they gave. Otherwise, we can use the default IBIS model. Um, okay, so what I'm going to do is first identify DC net. Yeah, we can put as 5. Sorry, volt. Okay. Okay, I think let's skip this for a while. Um, Even the IBIS is gonna be in different voltage levels, so I'm gonna skip this. Let it determine. Okay, so assign model. Then yeah, so whenever there might be uh, okay, so you can like click and create model and press OK with this parameter, and this is the IBIS model that I was talking about. If you double click, so default model setup. Then if you click right here, yeah, so these are the various models that is available. um, yeah, we already chose the default one, 2.5, 10 pico receiver. So we are looking for bidirectional, as you can see, bidirectional, not receiver, bidirectional, and 10 pico 2.5. Yeah, so we have all validated. So it might be like red, and then once you assign them, create once you create the model and click OK, after choosing this corresponding IBIS model, it's gonna become green, and you click OK, and then um, yep, that's all from here. Um, modify. Okay, I'm trying to remember. Yeah, okay. Meanwhile, let me save the workflow. Um, so this is topology test one. Okay, I did save it. I'm gonna come back to topology workflow. I'm gonna select the net that we are interested. Yeah, and so I've selected the nets right here. You can search the net from here. Start tab. Sorry. Yeah. So let's say, for example, if it was here, you can either select from the layout directly, or you can search the from here. Test TST start tab. Yeah. So you can double click, or you can just click here. It will shift to the other side. Just apply. Okay. Just selected the net, and you can see the 3D geometry of the net part. So it is from the bottom, and it goes to the top through here, and then it drops over here, and then it comes down here as well. Mm, and then what else? Yeah, so 3D view, and then we can start extracting. You just need to click start extraction. Yep. So as you can see here, it is routing from 57 to 59 device, and first of all, it goes a 32 millimeter, and we have via, and then another trace on the top, and then another via, and then again a trace. So that we can even calculate them as well. Like for example, this is 32 millimeter, right? From U56 U56 to the first via, it's 32 millimeter. So this is U50 all off symbol. Yeah, this is U56. So I'm gonna hold off C line. Right click, so elements. Yeah, this is 32.23. 32.23. Then it goes to the VR, and then we have a trace, which should be 5.76, right? So I'm talking about this net right here. So element 5.76, yeah. So this is the net that I'm talking about, and then yeah, um, once we have this, we are ready to simulate. To do that, we have to set up the uh, signal first. Yeah, so this has been generated. The files related to this has been generated on the work folder right here. Let me bring the folder, you guys. Yeah. So this is my work folder, um, and this is the layout stuff is right here. So we created what, as you can see here, it should be under test sig and test sig test underscore sig dot top x. Um, so test sig text sig underscore top x. This is the topology files and files related to topology, right? Yeah. So what we're gonna do is first we're gonna hold on. Yeah, I'm gonna double click right here, and then we have our IBS model assigned right here. Our default IBS, I would say. ASI models. Let's check. Uh, Not here. Here. Yeah. So default is the one that we are looking at. Um, yeah, cool. And then what else? Similarly, we can check for this as well by double clicking on it. So yeah, it has the same model because we are using the default IBS model. Then next, we're going to click check connectivity. Uh, yep. So we are good. And what else? What else? So I'm going to click check right here. Or if you want to change, do you want to continue simulation? Okay, I'm going to click no. Um, and then because that was necessary, yeah. So we have to make one of them as transmitter, either U56 or U59, right? So I'm going to select the which one is transmitter. So let me select this as a transmitter, um, U59. I think either way is fine. Let's select this as make transmitter full, and then I'm going to check. Yeah, we're good. And then next will be like next will be sets analysis option. Then what else? Yeah, so this is where we're gonna set up the patterns of the signals. Um, okay, so we have these two devices. One, we have set up 59 as the transmitter and 56 as the receiver. So for this transient simulation, we're gonna need to set up the stimulus, right? So as you can see, this is the TXIM model, and this is the model that we chose, the default model. And similarly, this is the RX model, and we chose this, and we chose bidirectional IBIS model. Now, okay, let's change the number of it to say um, 16. 16-bit, and instead of this 1010 pattern, let me define the pattern right here. Bring this window. Let's go to random and then seed one number of signals. Uh, 128 4. Okay, I was thinking something. Okay, so yeah, sorry. Um, this is a simulator that we are using, the IO model, transmitter, receiver. Um, what else do we need to do? Okay, so we got a random pattern, as you can see, the 16-bit. Um, now, what else do we need? Okay, so nonetheless, let's start the simulation. Yep, so this is the pattern that we have, that we receive, and let's enable the transmitter as well. Okay, yeah, so data rate is at 1 gigabits. Okay, let's say 0.01, and let's reduce this to 2-bit, and let's say, okay, let's change this to random again. It doesn't matter, 10. Fine. Let's start analysis. Okay. Interesting. And 0 to 2.5, right? So because we are simulating for 2.5. Signal. Yep. So if you see the eye diagram as well, minimize this. Yep. So this is transmitted signal, and this is the received signal. Right? So likewise, we can play around with various signals. Um, what else do I need to form? Okay, let's change this to 1 4-bit 10. Say 10. Start simulation. All right, this is what we have. Let me fit. Measure. Okay, we can measure the rise time, fall time, the difference, all those things. And the transmitter. Yep. So this is my transmitted signal, this is my received signals. And power and ground, as you can see. Yeah, this would be the power, which is 2.5 volt, and this is ground, 0 volt. So likewise, we have the same for the receiver as well, and transmitted signal again, and the received signal. And this is the eye diagram. Alright, so that's all for the Sigrity, and we have to make sure to model the IPS model accurately, and impedance and all those things. Yep, that's all for this Sigrity test. Cadence Aurora. Ciao guys.